Hello, my dear students. How are you all? I am fine. I am Khandakar Fazle Rabbi, lecturer, Department of Chemistry, Milestone College, Uttora. My dear students, during this pandemic situation, welcome you all to our online chemistry class. Dear students, today we discuss about some important multiple choice question from chemistry first paper, chapter 3, periodic properties and chemical bonds. My dear students, this is our first question. How many S block elements are there in the periodic table? My dear students, we know that in a periodic table, 4 block elements are there. They are S block elements, P block elements, D block elements and F block elements. My dear students, in F block elements there are present 14 elements. In P block element there are present 36 elements. In D block elements there are present 41 elements, and in F block elements we know that there have only 27 elements, my dear students. So according to our discussion, we can say that the correct answer is option A, that is, my dear students. Now our second question, my dear students, which one is the first member of P block element? My dear students, we know that the general electronic configuration for P block element, that is NS2 NP126. This is the general electronic configuration for P block elements. For first member, my dear students, their electronic configuration will be NS2 NP1. So my dear students, if we see the outermost shell electronic configuration of magnesium, that is 3s2. For cesium, that is 6s1. for boron, that is 2s2 2p1, and for nitrogen, that is 2s2 2p3. So my dear students, according to our discussion, we can say that the correct answer is option B. Now my dear students, our third question, which one of the following is not transition element? So my dear students, at first you have to know what is transition element. The D block element which have at least one stable ion containing partially filled d orbital in their outermost shell are called transition element. So my dear students, if we see the electronic configuration of stable ion of nickel, that is nickel 2 plus, and the electronic configuration of nickel 2 plus, that is 3d8. For iron, stable ion Fe2 plus, electronic configuration 3d6. For chromium, that is chromium 3 plus, stable ion, and electronic configuration of the stable ion, that is the outermost shell electron 3d3. And for scandium, my dear students, stable ion is scandium 3 plus, and stable ionic electronic configuration, that is 3d0. So my dear students, according to the definition of transition element, we can say that scandium is not transition element. So the correct answer is option D. My dear students, this is our next question. Which one of the following is smaller in size? Here the given beryllium, boron, nitrogen and oxygen. My dear students, we know that all the elements present in the same period. In a same period, my dear students, if we go from left to right, then the size of that element decreases. So according to this reason, this we can say that oxygen is the smaller element. Next question, which one of the following ion forms colored compounds? My dear students, we know that transition element forms colored compound. here we can see that scandium is only d block element, but it is not transition element. Mercury is not transition element, zinc also is not transition element, but iron 2 plus, stable iron 2 plus, which comes from iron is a transition element, so iron forms colored compound. This is the correct answer, my dear students. And our next question, which order is correct in case of ionization potential? My dear students, ionization potential increases from left to right in a same period. My dear students, here nitrogen, oxygen, beryllium, boron present in the same period, but my dear students, there have some exception. According to ionization potential, beryllium, boron, nitrogen, oxygen, the smaller size is here oxygen is the smallest element, so the ionization potential of oxygen will be higher, but here we get some exception according to their electronic configuration, my dear students. If we see the electronic configuration of beryllium, this is beryllium 4 1s2 2s2, for boron 5 1s2 2s2 2p1. If we see the electronic configuration, beryllium here s orbital is fulfilled, and that's why this is stable, and for that case the ionization potential of beryllium is more than boron, my dear students. And similarly, if we see the electronic configuration of nitrogen 7 1s2 2s2 2p3, and oxygen 1s2 2s2 2p4, here we can see that the electronic configuration of nitrogen, the p orbital is half filled. We know that half filled and full filled orbitals are more stable than partially filled orbital, and for that case the ionization potential of nitrogen is more than the ionization potential of oxygen, because the p orbital of oxygen is partially filled. And according to our discussion, we can say that the ionization potential of nitrogen is more than oxygen, and the ionization potential of beryllium is more than boron. So the correct order is boron is less than beryllium, and beryllium is less than oxygen, and oxygen is less than nitrogen. The ionization potential of nitrogen is higher. So the correct answer is option C, my dear students. My dear students, here given our next question, which one is correct order of electron affinity? Electron affinity is defined as the energy released when 1 mole of electron is added to outermost shell of 1 mole of isolated gaseous atom to form an ion, my dear students. If we see the elements here given, fluorine, chlorine, bromine, iodine, we can see that all these elements present in the same group, group number 17. And according to electron affinity in a periodic table, in the same group, if we go from top to bottom, the electron affinity decreases. So here we see that, so here if we see fluorine, chlorine, bromine and iodine, if we go from iodine to fluorine, the electron affinity increases, my dear students, because the size of the atom decreases. But fluorine, the size of fluorine is very small, so the electron density is very high in fluorine. When one electron is added to this fluorine, then the electron affinity of fluorine is decreases than chlorine, and that's why the correct order is, first one is chlorine, then fluorine, then bromine, and then iodine. And according to our discussion, we can say that option D is the correct answer. Now, my dear students, our next question: for which element electron affinity is 0? My dear students, we know that electron affinity of inert gas is 0. So here the correct option is option D, because neon is inert gas. My dear students, our next question: which of the following compound is more covalent? My dear students, to discuss about this question, at first you have to know what is Poisson's rule. My dear students, Poisson's rule: smaller size of cation, larger size of anion, and higher charge in cation and anion, and cation with electrons in d and f orbital. In this case, polarization occurs more, and that compound is more covalent, my dear students. Now, if we see these compounds, here all the anions are same, but for cation, here magnesium 2 plus, calcium 2 plus, aluminum 3 plus, and sodium plus. So, my dear students, if we see the cation, we can say aluminum is the smallest cation among these cations, and the charge density of aluminum is more than others, and that's why aluminum chloride is more covalent. So the correct answer is aluminum chloride. My dear students, our next question: which compound is more soluble in water? Students, we know that ionic compounds are more soluble in water. So if we see here, all the cations are same in silver chloride, silver fluoride, silver bromide, and silver iodide. Cations are silver, and so we cannot explain the character by cation. And if we see the anion here, this is chloride, fluoride, bromide, and iodide. And according to Poisson's rule, my dear students, when the size of anion is large and charge density of anion is high, then that compound is more covalent. So according to our discussion, we can say that silver iodide, silver bromide, silver chloride, and silver fluoride, silver iodide is more covalent. So we can say that silver fluoride is more ionic, and we know that ionic compounds are more soluble in water. So our correct answer is silver fluoride. Now, my dear students, our next question: which of the following compounds melting point is highest? My dear students, we know that the melting point and boiling point of ionic compounds are higher. So if we see here Poisson's rule, the fourth option, cation with electrons in d and f orbital. If we see these compounds, calcium chloride, ferrous chloride, copper chloride, and zinc chloride, all the anions are same, and iron, copper, and zinc contain electrons in d orbital. So all these compounds are more covalent, and so this is more ionic, and that's why the melting point of calcium chloride is more. So this is the correct answer, my dear students.